Yeah, I was going to say, we supposedly had the hottest July on record, but it's really cool here. I mean, very pleasant weather here, very fall-like. So that I thought that was amusing. Good morning, Ian. How's things in
Morning,
Ireland?
Harry. Morning, Dennis. Sorry, say again?
How are things in Ireland?
Well, it's alternating from hot weather to cold weather. But whatever happens, the people who've made up their minds about anything are using it to justify their preconceived ideas.
Right. I'm putting this up here as a sort of a kind of a roadmap. And really the question is this settled science? They say that climate change, 97% of scientists say, that apparently has been debunked pretty thoroughly. So that's apparently not true. In the first part, I'm going to, talk a little bit about what's this. There's a question about science. Global warming. This used to be called global warming, and then it got changed to climate change, and that may not have been a very good idea. Some of the ideas I want to talk here, what does it mean to have a global Earth temperature? What's that really mean? That's kind of a, now, to the average person, I don't know that really means anything. It doesn't really mean anything to me particularly. If you're saying the Earth is warming, I might say, oh, that's good because I live where it gets really cold in the wintertime. So maybe if it's not getting really cold in the wintertime, that's better. Okay. And then we have the issue of these proxies, what I call proxies. Which are things that they say are happening that are because they're due or caused by the fact that global temperature, global warming is happening, which they call climate change. And so what does this really mean, climate change? I'm going to talk about Richard Lindzen, who mentions that. And so then, my next question is, maybe we shouldn't be talking, as scientists, they should not be talking about climate change and should be talking about global warming, because climate change can mean as many different things as global warming can mean. And then, the other problem is, what are the indicators that climate change is actually happening? What are these indicators? Okay, and so Richard Lindzen points this out. He says it's kind of absurd to use this global warming number as the single number for the issue that's involved. And I don't really know enough about this to really comment on it intelligently. If somebody listening does, we can discuss that in the discussion. And I looked at this, and and it's about calculating averages, the mean, the lowest temperature, the highest temperature, taking the mean, and then so it's a complicated procedure. And does the number that it produced, what does that really tell you? Okay, and so the issue then is, since they're saying, oh, we can't allow this global warming to increase over 1.5 C based on computer models, which involve a lot of assumptions. That this number 1.5 C seems like an arbitrary number. I guess if you want to delve into where that came from in the IPCC, that's pretty obscure stuff. Okay, so what is this climate change temperature? What does it really mean? What does it mean, as terms of something that you can talk about physically? And then it turns out when you try to do that, it's kind of vague, because what is the climate? Okay, so then you get into this issue of what is climate? Well, I think it turns out that we don't really know what climate is. or what our climate is. Okay, that's another issue. And people who are critics have sort of exploited the point. And then here I'm going to, these are some of the things that are people point to that are essentially proxies for the fact that climate change is bad. Okay, all these things that they're pointing to are bad things. They don't point to good things. So, Arctic sea ice is melting is one. Glacier ice melting in Greenland is another one. Here's one that I added is number of Atlantic icebergs. I'm going to talk about that because I had a experience at a presentation regarding icebergs. Then there's the famous polar bear population. Climate change is killing polar bears. So because polar bears are dying, their climate change is happening. The Great Barrier Reef in Australia, we're claiming that it was being killed by climate change. Here's one that you can quantify: hurricanes increasing in number and strength. And this is good because it's led to some people who have made some conclusions, and different people have reached similar conclusions. So that's a testable thing there. Another one is that lakes are shrinking and dying. Great Salt Lake in the United States has been put forward as dying as a result of climate change. The Great Lakes, if you're familiar with U.S. geography, we have the Great Lakes in the northern part of the country. There was claims that these lakes were drying up. Then you have increased drought and floods. I think we've heard about that recently this summer. In Europe, I think they're claiming that France has a major drought. I saw that on the news. I'm not really that familiar with European weather, but they claim in the United States that there's a major drought in the western states of the United States. And there was a lot of publicity this summer about that. And talk a little bit about that because that's an irony. Then, of course, it's summertime, so we're going to get more frequent heat waves, right? And that's supposedly associated with increases in forest fires. And so the heat, the severe heat is, and drought, of course, drought is associated with forest fires. And then there's the famous sea level rise, which I was exposed to many years ago here in the state of Virginia, because that became a hot button political issue here in Virginia, because Virginia is sinking. The level of Virginia is sinking, and they've tried to connect this fact that we're sinking with the fact that climate change. So the fact that Virginia has this issue of the sea level is rising. It's rising more because Virginia is sinking, not because of climate change. Okay, so those are kind of some of the points. All right, and then at the end, let's get down here to the conclusion. Okay, so then what were if we look at these claims that they've been making and we ask, okay, how did these forecasts or predictions, if you will, science makes predictions, how many of them turned out to be wrong? Well, all of them. And how many of them turned out to be true? None. Now, you may or may not disagree with that, but I think that's kind of my view of it based on looking at a number of these websites that I've looked at. Now, I don't claim to be an expert on this, so I just based on these websites. So I'm going to refer you to the websites. Let's see here. Any questions?
I wonder if Virginia is sinking because of all the coal mining.
I don't know about that.
Well, Saudi Arabia is having a problem with all the oil they're sucking out is causing the desert to sink and subside.
Well, that might everybody see Richard Lindzen here.
Yes.
He's apparently, thinks that this whole business is ridiculous. This whole climate change is ridiculous. So this is a guy who's an expert, apparently. I mean, a qualified, good scientist. And I guess when he was employed by the universities, he wasn't allowed to, I guess it was in politic or something to criticize. But since he's retired, he's been extremely critical. And if you're interested in, you can look him up, Richard Lindzen, you can look him up on the internet. So I think this is, I've seen a number of talks that he's given, video talks that he's given. It's, I found him to be pretty persuasive. So some of the ideas that I talked about, he talks about, he says the main issue is confusing weather and climate. He makes that down here. He talks about, says at the heart of the nonsense is the failure to distinguish weather from climate. Okay. And I think that's an interesting point. That was the point I was trying to make in the beginning about the global temperature and, what does it mean that, this temperature is increasing? So now the question is, most of these things that they've talked about, which are proxies for global warming, which has become translated into climate change. Now, I'm wondering if maybe the reason for doing that is global warming was too abstract. So we had to have some concrete things to talk about, concrete bad things. They don't talk about concrete good things. Some, the critics maintain that increased carbon dioxide increases crop yields, vegetation growth. And so, they don't talk about that. They talk about the bad things. So what are the bad things? All right, one of the bad things is, I'm gonna do a new share here. And this is Tony Heller's website. Now, Tony Heller, I love this guy because he uses data. He talks data. And his data isn't just graphs of, oh, here's this graph that shows the temperature of the earth, the, temperature, climate change, global warming, and they show you this plot graph and it shows the temperature is increasing and that's bad. Okay, now Tony Heller, he uses different kinds of data. And since they've introduced the idea that weather is changing, okay, so weather, of course, weather is always changing, but because climate change is affecting the weather. Okay, one of his things is he says, okay, let's examine weather data. And this is kind of the big criticism that critics or dissidents, if you will, have. And so here's his website.
Yeah, now we see it.
Okay,
Yeah.
this is Tony Heller's website, realclimatescience.com. He puts out videos on YouTube that are based, and then he has blogs. And if you go to home, it'll be the most recent blog. Then he has the past blogs. Okay. And I think the one that I've selected here is hiding the decline in extreme weather. Okay, now one of the claims is that extreme weather increases as a result of climate change. Now, this climate change, if they're correct in what they're saying, has been going on clearly since the 1970s. So they've been talking about global warming and increase in heat for quite a long time. So we should have some, you know, if they're right, we should see the results of this. Okay, now the prediction of increased hurricanes turns out to not really, and this turns out to be one that's not really panned out for him. And he has lots of data in here. He talks about historical hurricanes, okay? Now, the problem is if you go back in time, it's, you know, there are hurricanes, you know, in past history that were really much worse than hurricanes that have occurred recently in the United States. So that's a problem. So, and he talks about this, he has these, you know, talks about the different ones, and then he talks about fatalities. Okay, fatalities have been going down with time. That's a kind of an important fact. And then, you know, all right, so he says, based on his data, that U.S. landfall hurricanes are decreasing. So there's his analysis of it. So that doesn't really look like the claim of climate change that hurricanes are going to be increasing and being stronger is really proved out to be correct. And he's got a chart here of landfall. So you can look at that. So we can sort of, you know, he's looked at tornadoes. Doesn't look like tornadoes are increasing in frequency or strength. So that's kind of not really worked out too well. I want to talk a little bit about Arctic sea ice, because I went to a presentation, I don't know, probably around 2014, something like there. And the guy was talking about the Atlantic Ice Patrol, Coast Guard. I think the Coast Guard runs the Atlantic Ice Patrol. And I'm a buff on the Titanic. You know, and the Titanic was sunk by an iceberg. Well, of course, we all know this. Okay, so what he gave a talk was about, you know, how the Coast Guard tracks icebergs. And at the end of his presentation, people in the audience wanted to know, are the number of icebergs in the Atlantic Ocean increasing because of climate change? And the answer was no. And I thought, that's pretty interesting. Well, okay, so if we go to Tony Heller's website, I don't really, you know, I forget exactly, we can find it here. But he presents a lot of charts and graphs that show that the Arctic sea ice extent isn't shrinking to zero, as had been claimed by Al Gore. And he has a number of videos. Al Gore claimed that the Arctic sea ice would disappear, and it could happen as soon as 2014. Let's see, it's 2022 now, not 2014. Did that prediction pan out? No, it didn't. And what Tony Heller does is he presents data on, and this is really good stuff here, showing the Arctic sea ice extent, and it varies over time. And it isn't shrinking away to zero, and it shrinks for years and then it increases for years, and it's a cyclical phenomenon. And he also discusses the fact that because in the past, the sea ice was increasing in extent, that people were talking about a new ice age. They were saying that the Earth is cooling. This was during the 1950s and in 1970s, I think they were saying this. Is all kind of documented here on his website. You see the new website, or do I need to do a new share?
We see it.
The peasants are revolting. You see that?
Harry, on the previous slide, there was an entry about doubling the hockey stick. Have you looked into that?
Well, no, and then that's why I'm
Well,
really hesitant about
before-
going to all these different websites.
Since
you're
that was
interested-
on the previous slide, you might want to look at it. What happened was that Al Gore knew that CO2 was not the a problem with the alleged warming, but he had to make that case. So he put up two charts that looked like hockey sticks, sudden rises.
Right,
The problem was that CO2 rose 600 years after warming because the CO2 is in the ocean, and when it warms, unlike other gases, CO2 escapes from water as water is warmed. So even Gore knew it was a fraud back then. Just thought that was a really key point.
well, like I say, I was a little bit hesitant to, do this because this is a lot of people, people out there, probably you people out there listening probably know more about it than I do. I mean,
Yeah,
I
I've studied
just-
this. I studied this and probably know it second best after special relativity, and I agree 100% with what you have said.
All right, well,
That's what I found as well.
well, I'm just going to go here and I'm trying to talk about sources of information. Okay, and that's kind of my, that's why I'm talking about the websites and because it's a big topic and you can argue about a lot of different things. I like this other, these are websites that I basically found interesting and informative. And so this one is Climate Discussion Nexus, and he also does videos. This one is Climate Discussion Nexus, and he does have videos. They're very good videos. He puts one out. He has a newsletter that he puts out on Wednesdays. That I get that newsletter. That's a good informative newsletter, I think. One of the things I liked about Climate Discussion Nexus is he talked a lot about the polar bear issue and the debunking of the polar bears are dying. The polar bears are all dying. Okay, and this has become a big thing in the climate change people. We're killing the polar bears. Well, apparently, that was a good thing, I suppose, in that it caused scientists to actually look at how many polar bears there were and what was happening to them, and they found out that there were more polar bears apparently than they thought, and apparently this dying of the polar bears is not really happening. And this woman, Susan Cockcroft, has written a paper on that, and she's done some interviews or videos. You can search YouTube and see the videos where she's interviewed, and so she's kind of debunked the polar bear thing, the polar bear claim, if you will. Okay, now this here is interesting in that you see here's the Younger Dryas curve that off here in the corner. And what this is there's a sudden decline in temperature. And what is this? Between 15,000 and 10,000 years ago, there's a sudden decline in temperature and then a sudden rise in temperature followed by a steady rise. Now the question is, why is that happening? I mean, certainly was CO2 changing? Climate change is that what's causing this? Anyway, that's an issue. I talked about sea ice melting. That's been debunked. Oh, the glacier ice melting in Greenland. I talked about that because the thinking was that the icebergs in the Atlantic Ocean would be increasing because the glaciers are melting in Greenland. And because the glaciers are melting, they're producing more icebergs. And there was no increase in icebergs, according to this expert. And so then it turns out that, these these glaciers in Greenland aren't melting as they claim. There is a lot they were claiming that the glaciers are retreating, and this was because of climate change. Well, Tony Heller has got a lot of information on this on his website, where he shows the what he calls the mass balance, which is the amount of snowfall in Greenland, and you know, and it's cyclical. It varies. You know, in past years there wasn't as much snowfall, but in recent years it's increased. So these climate changes that are attributed to climate change are really cyclical changes. And Tony Heller says, and the people who dispute a lot of the climate change claims say that this is due to changing ocean currents and wind patterns and that sort of thing. And these changes are cyclical. They're not caused by increasing in global temperature as a result of burning fossil fuels. So this raises the issue of, do we really know what our climate is? And I think the answer is we really don't. So we don't really have a baseline of what the normal climate is in order to say that global warming or CO2 emission increases is actually causing a change in the climate, because we don't really understand what the climate is to begin with. That's kind of the point, I think. All right, any comments before we go to session 2?
Well, regarding climate, that's normally something that takes a considerable period of time and is differentiating from the weather changing. You have climate change over 1,000 periods, 1,000-year periods, and you go from, let's say, having lots and lots of grassland to having trees or something like that, some major ecological change. So I think what happened was they had the name global warming, but then they went through a period where it wasn't warming. So they had to change the name to something that was more general and vague, so that if temperatures dropped, they could then go to global cooling or something like that. But so far, even though they changed the name, they haven't changed the basic thesis at all. You would think that if you're going to change the name, there must be some fundamental reason, and your thesis must change in a certain way. But that was not what happened.
I think part of it is that you can blame weather on climate change, because climate change is now ambiguous.
Yeah.
And, okay, can you see the chart of sunspots now?
Yes.
Okay, this is a chart of the sunspots, and we see here that I think we're getting ready to turn off here. But anyway, you see that this Maunder minimum 1650, 1675, that's correlated with a cold period.
Yeah.
And then here around 1800, I think they call this a little ice age. And, you know, there's the minimum of sunspot decline there. And then, you know, we notice that we get peak of sunspots in the 1950s. Okay. And then the sunspots are kind of trending downward in recent years. So you could say, like, for instance, Tony Heller suggests that the temperatures are actually decreasing since the 1930s and the middle of the, so, you know, some people say, well, the temperature is actually going down. Well, question is, what temperature are you talking about? The temperature measured at the center of the earth, surface of the earth, the temperature measured at the tops of the clouds, the temperature calculated by these people who calculate the temperature based on thermometer measurements. Anyway, there's a lot of different ways to talk about the temperature, but anyway, sunspots have been decreasing, so that might imply, if you believe the sunspots are an indication of solar energy output, that we should be cooling off a little bit. that might be in agreement with some of the measurements.
Harry, you said something about heavy rains in the Southwest where there's supposed to be a drought.
Oh yeah, that was one of the claims they were talking about drought. The news was talking about the drought in California
Yeah.
and then, but it turns out that this past summer, it's just been raining like mad, and Death Valley was flooded out. There's a video on the internet where this guy is taking a trip through Death Valley, and the road is just completely wiped out because of flooding in Death Valley. So, you know, the business of floods and drought and floods, it's cyclical. Okay. You know, the flooding, that seems to be a weather issue. So if you're going to connect flooding, increasing in flooding, and attribute that to a change in the climate, that's very difficult to do because flooding is, you know, it's kind of random. And here in Virginia, we had a big flooding event in Madison County number of years back. It was kind of similar to this flood that recently occurred in Kentucky. You know, it just wiped out. This thunderstorm came in and it sat over top and just flooded everything. And we had a similar event here where I live in 2011, where this thunderstorm came and it just poured rain for over an hour and a half or something like that. And it wiped out, I mean, it wiped out a lot of stuff. It wiped out the museum. We have a wildlife museum, completely wiped it out, you know, because they had these outdoor wildlife exhibits and they all flooded out and were destroyed. And it was just, but since 2011, we haven't had anything even to compare with that.
Harry, about
10 or 15 years ago in Atlanta, they had a so-called 500-year flood.
Yeah, yeah, all right.
Sorry, just on this graph, the vertical axis is the number of groups of sunspots, is it? And also, I thought the sunspot cycle was sort of 11 years. There seems to be two peaks between 11 years. In other words, four sort of cycles within 22 years.
Well, that's a good point. You know, there's some argument about when, how to count the numbers, and you know, the reason I picked this chart is because you can see the you know, the Maunder minimum pretty clearly, and that's and the little ice age is pretty clear. And then on this page, I have the page. There's a whole bunch of charts here that you can, you know, different sunspot. You know, you can count it a lot of, you know, you see there's a lot of different charts, you know, a lot of different interpretations of how to present the data. And here's one here that's here's a different one, sunspot that goes back to 1700. Okay, and it points out the Maunder minimum, then what they call the Dalton maximum. Then we have this modern maximum. Now the modern maximum is 1955, which, you know, I'm an amateur radio operator, you know, a ham radio guy, and there's all these stories about propagation on the high frequency bands right here at this peak. But this peak doesn't really correspond with any real increase in temperature. In the United States, the severest temperatures were like in the 1930s and the early part of the the 1930s, 1935, it was bad here in the United States. Now, Tony Heller talks about this. He has some videos where he talks about this, and he talks about all the bad weather around the world in the mid 1930s. But according to Tony Heller, who uses the Weather Service, U.S. Weather Service data, okay, that's in their files, which is temperature measurements not adjusted by anybody. In other words, they haven't fiddled with the temperature measurements. He sort of shows that 1935, 1934, that area was really bad in the United States. It was really insufferably hot. There were a lot of days where the temperature was over 100 degrees. Okay. So this brings into this other issue about how you're going to declare that it's hot. Okay. Let's see, I've got a newspaper clipping here that my neighbor gave me. Not sure how to unshare. How do I let me.
You did, if you can make your clipping the active window.
No, I got it here in my hand.
Oh, I see. Oh, I see.
All right, when it says July sets overall U.S. record for overnight warmth, hottest in 128 years. Yeah, right here it says that. Okay. Well, what they're saying is it was hot at night. Okay, so what does that really mean? Okay, so it was hot at night. The temperature didn't cool off at night. All right, well, some people say that's because of air conditioners and the fact that where these measurements are being made is, parking lots are nearby, and urbanization has essentially caused that the overnight low temperatures are increasing. But is this an indication of, quote, climate change? So this gets into the point I was trying to get at earlier, which is how do you measure the temperature? Do you measure it in terms of the number of days over 100 degrees? Do you measure it as the peak temperature for the entire year? In other words, what's the peak temperature? It could be 110 degrees. Okay. Or do you measure it like here where I live? We're really concerned about it rarely gets above 100 degrees. If it gets above 100 degrees, that's bad. But we count how hot it is by how many days over 90 degrees. Well, in July, we had a lot of days and it was over 90 degrees. Then the other question is, well, what about in the wintertime? What do you take the minimum temperature? Well, this whole business of global warming is they're taking averages, okay, and I think they're taking the average between the hottest time of the day and the lowest time of the day, and then they're taking that over every day. I don't, so there's a lot of different ways you can calculate this.
Well, Nick was saying that the present algorithm for calculating isn't doing the job, so they're trying to modify it so that the temperatures will appear to go up. So isn't that right, Nick?
Yeah, first of all, there was Climate Gate, where they actually fiddled with the data and came out with fake data. And then after that was discovered, what they did was something that Harry alluded to. Those stations that they were gathering data from that were showing rising temperatures were picked, and the ones that were showing lower temperatures, they got rid of. So by changing the data points, the data collections set, they weren't comparing apples with oranges. They just were trying to fiddle it to make the data look like it was supporting the thesis. And one of the examples was that some of these stations were right behind air conditioners in parking lots, as Harry alluded to, in cities. So obviously then you're going to have, if you have a major change like that, someone puts an air conditioner in front of your data collector, then obviously you're going to have a lot of increase in heat. And, I've seen studies that said when they claim that some year was a new record high, the amount that it was hotter was far less than the inherent error probability. So there's a lot of funny stuff that's been going on. I think that what global warming, right from when Al Gore started this, it was really never science. It was political, and it was really political against it was anti-fossil fuel. And unfortunately, this deception has now led us into a total crisis because people have rushed to get rid of fossil fuels, and they're going to cause a tremendous amount of problems having done that.
Well, they have another problem, which is if they succeed in doing this, then they're going to have to get rid of fertilizers. And we already see this. Talk about that a little later. Here's can everybody see this? This is the U.S. Climate Reference Network. Can you see that? Is that on the
Yes.
screen?
Yes.
Okay, this is because of these questions that you mentioned, which is the Weather Service temperature stations. They're in places that are really not very good. They're next to parking lots. They're near air conditioners. Okay, so they did this thing called the U.S. Climate Reference Network, which is supposed to be the gold standard. And guess what? Do you see any temperature increase here?
No, no, not on the average. No.
And it's been in operation since 2005. Does this show any global warming surface temperature increase?
No, it just shows the need to change the title from global warming to something bigger.
Right. Well, I guess what I'm saying is, there's a lot of different data sets that you can choose. And, so there's this argument about which data set really proves the point. And, and then you get into arguments. Tony Heller, if you go to his website, I really like the fact that what he does is he points out, because he's using the Weather Service temperature database, okay, that's not been tampered with or processed or anything. And he shows things like, number of days where the temperature is above 100 degrees, number of days the temperature is above 110 degrees. And then he's got a map that shows you these temperatures across the United States. And so in a recent video, he talks about this claim that July, this past July, was the third hottest July on record. I don't know if you heard this claim. Now, we're talking about the United States, of course. And he sort of takes that and shows you these weather chart, the temperature charts, and he goes state by state. It's kind of tedious. But in effect, basically, yeah, you can make the claim that it was the hottest third highest July on record, but you have to sort of fiddle with the data to get to that conclusion, as Nick said. So then, it's like, okay, what data points do we choose? Okay, so this business of measuring temperature is fraught with, trickery or whatever it could be. Not saying it is, could be, a lot of trickery involved. Okay. I hope I covered all of the such.
One topic that I find relatively lacking in what little I know about this whole story of climate change is a lack of possible negative feedback mechanisms which would stabilize things. For example, like an air conditioner thermostat is a negative feedback device. Okay, like for example, if carbon dioxide goes up, shouldn't plant life also go up, which would then tend to diminish carbon dioxide? That would be a negative feedback mechanism. So in summary, I'm seeing a lack in this whole story that's been presented over the years on climate change. And by the way, Harry has done a fantastic job here today to summarize the faults in that. But one additional fault, I think, is this lack of analysis of how one variable, like sea level or carbon dioxide concentration in the troposphere or whatever, affects other variables. And are there negative or even positive feedback mechanisms involved? In other words, applying some engineering to the whole situation.
I would say that this has probably been discussed in some of the forums and
Okay.
the main thing is, here's the point. The main thing is the only feedback mechanism that is really talked about is the feedback mechanism that makes climate change worse. So they say that the Arctic ice is melting and that will melt the permafrost in the Arctic. You know, if you're familiar with what permafrost is, it's like swampland that's frozen. And that will release all of this methane that's trapped in the permafrost. So what they're claiming is that there's no, that the issue is not that there are feedbacks in the negative direction, they're positive, they're feedbacks in the positive direction that make it worse. And as far as I know, those are the only.
Well, to use your example, Harry, wouldn't, I've heard that the methane release would provide a heat shield to some extent and therefore lessen the heating from the sun rays arriving on Earth. And that would have a negative feedback and reduce temperature again.
Right. Now, there's a controversy about clouds. Okay. If you believe that the temperature is increasing, then some people say the clouds would be increased. Increasing clouds means that the albedo is increased, which means that the solar energy is reflected by the clouds, and so it doesn't get to the ground. And so therefore that would be a feedback mechanism as you were talking about. But
exactly.
Can I
So
make
in other words, relatively unexplored, perhaps, at least to my knowledge, which is limited here, are negative feedback mechanisms, which would sort of, to use a biological term, make create homeostatic values, much like osmosis in animals, but body fluids is regulated and so forth by negative feedback mechanisms to create a homeostasis. But that's not talked about because people want to have this political view that Nick mentioned of promoting this climate change in order to, I guess, make the rich richer.
yeah. Did I talk about the Great Barrier Reef? I don't think I talked about the Great Barrier Reef, but that supposedly the Great Barrier Reef is dying. Now, I wanted to make a point here. A lot of this, I think, stems from
Sort of like Mark Twain.
a lot of this stems from the hydrofluorocarbon thing. Okay, if you remember, they discovered that there was this controversy. A scientist put out this paper where he claimed that hairspray hydrofluorocarbons would destroy the ozone layer.
Right.
Okay. And then guess what? Magically, they suddenly discovered that there's a hole in the ozone layer.
Yes.
And this was terrible. It was a horrible, horrible thing. And we had to do something about it. And the politicians went and, outlawed hydrofluorocarbons. Am I saying that right? Fluorocarbons? Anyway. One of the ones that is outlawed is halon. And halon is the most effective fire suppressant known to man. And you cannot, my understanding is you can continue to use it, okay, but it's kind of restricted. Here in Virginia, we had a fire about in June, I think, where they had an excursion boat, the Spirit of Norfolk. Okay, it was a fairly large yacht type boat, excursion boat, had a bunch of children on it who were celebrating the end of the school year. Now, these are young children, first graders. And it caught on fire and the fire suppression system did not work. And the boat was completely destroyed, but luckily all of the children were rescued. And I mean, this is a problem. I mean, they banned the most effective fire suppressant known to man Okay. And so when you hear about all these deadly fires, you wonder, would halon have stopped that from happening?
Yeah, right.
Another, sort of a similar thing, they outlawed DDT because of Rachel Carson wrote a book called Silent Spring, where everything was supposed to die. And now people are getting malaria again all over Africa. DDT kills the malaria mosquito. And so now that people are dying left and right, or they're sick. If they're not dead, they're sick.
Yeah, that's another story where the environmentalists have sort of gone over the edge. Yeah, they were probably overusing DDT. That people have admitted to that, but banning it altogether apparently is, you know, that there's a discussion about that. That people are not really happy. Anyway, my point I'm making is with regard to the hole in the ozone layer, which apparently has not been repaired, and I don't really know enough about it, but my understanding is it hadn't fixed itself. So maybe the hole was already there before they discovered it. The business of the Great Barrier Reef might be another example of that. They suddenly discover that, oh, the barrier reef is dying and all these bad things are happening. It must be due to climate change. Well, now they've discovered, well, you know, the growth is making a comeback. Maybe that wasn't really true. So is that an example of a scientist pointing out to something bad that's happening and saying it's due to climate change, when the real reason was they didn't really know that much about reefs before that? They didn't really know the science of whether or not how reefs grow and what's the science of it. Is cyclical, what happens, what can happen. Okay, but they just said it's climate change.
Harry, about
About the reefs and stuff down here in Florida, they're saying that a lot of these sunscreens that people wear in the water can damage the reefs. So they're asking people to be careful about that. But I want to just mention that I have a kind of a different approach to this whole global warming, climate change thing. And that is to completely disregard all the evidence and just ask if the proponents of this global warming can explain the basic mechanism whereby CO2 and these so-called greenhouse gases can actually cause this warming effect. Now, I understand, and this piggybacks on James Keene's question about equilibrium and mechanisms. I understand how in a greenhouse you have glass that can trap the air. It's warmed up and the hot air stays in the greenhouse, and there's glass there that acts as a barrier. Just like when you put a sweater on and it traps the hot air close to your body and it makes you warm. But I do not understand, and I have not found any explanation of how CO2 and these other so-called greenhouse gases can trap this warm air next to the earth and cause this warming. Can anyone supply an explanation? Now, CO2, if it absorbs energy, it's going to radiate that energy at some point in the future. So how in the world can CO2 and these things act to cause warming? No one,
Well,
I've never read any explanation of how this can happen.
Well, supposedly it's because of the absorption bands and the absorption spectrum of CO2.
Yeah, but it absorbs energy and then it's going to re-radiate it.
Right. Yeah, that it's like we're supposed to believe what they're saying.
Yeah, I think right from day one of the global warming thesis, critics pointed at CO2 and pointed out that it could not be the cause of global warming. And more recently, Kent Mayhew has done a terrific job on debunking CO2 as a major cause of, or even a minor cause really, of global warming.
Well, let me just comment on that. Everything I've heard about this, and I'm not an expert, but my understanding is the CO2 effect is completely overwhelmed by water vapor.
Yes, yeah, absolutely.
And
Kent Mayhew goes farther and says that, unfortunately, because misunderstanding infrared spectroscopy. CO2 is weighted much more. It's only 0.04 part of the atmosphere, whereas nitrogen and oxygen actually have a much greater effect of absorbing radiation. And it was just the so-called infrared spectroscopy blunder that caused this false focus on greenhouse gases.
But Nick, you just mentioned actually that the CO2 concentration is lagging behind periods of increased temperature for hundreds of years, right?
Yes.
So CO2 is actually the consequence, not the cause of whatever cause of the increase of temperature.
Right.
Right. So
Yeah, it's
why to talk about that at all?
Well,
Of course, there are just two frequencies where CO2 can absorb the energy and I guess emits it. So
I'm not really sure we answered David's question.
Well, if you ever see a reference that explains how CO2 can cause global warming, please forward it to me. I'd love to see it.
Yeah, I'm not really a big, I don't believe it. And based on what I've, it's kind of a stretch, and they're claiming methane is a greenhouse gas. Okay, and the amounts that we're talking about are really, the amount of CO2 is small, and and they're talking about, in this recent U.S. government big spending pork barrel, they have money in it to get this. I find really amazing. They have money in it to pay farmers, to subsidize farmers to change the feed that they're giving to cows. Okay, because apparently if you change the feed that you're giving to cows, the cows don't burp as much methane. And I'm thinking, but the methane, how is that? I mean, how the emission of methane from cows has got to be trivial. I mean, come on. And I would think that fertilizer is a bigger issue. We've been using fertilizer for quite a long time, all around the world. And I don't know how many years has it been since fertilizer has been introduced. And that's supposed to produce nitrous oxide, which is supposed to be a really potent greenhouse gas, 300 times more than carbon dioxide. So one particle of nitrous oxide is 300 times worse than carbon dioxide. So now we can't use fertilizer. I mean, what? And most of the global warming is water vapor.
Yeah, the problem with global warming is not global warming. It's getting governments active and doing things. And they were always doing the wrong thing. They're always getting unintended consequences that are more horrific than the problem in the first place.
All right, let me tell you about unintended. My brother's a civil engineer. He apparently, here in Virginia, the Democrats forced the local power company to spend a lot of money on green energy. And of course, we have in our bill, in our electric bill, we have a percentage of our electric bill is taken to subsidize renewable energy. Okay, well, what they did in the state of Virginia was they went out to the west and bought land in which there was primarily forested land, chopped down all the trees, chopped down all the trees, okay, put in solar panels, and didn't do a very good job of stormwater management. Okay, now I know about stormwater management, and my brother is a civil engineer. That's his area of expertise. He said they completely messed up the stormwater management. So now all this water is eroding the mountains, and they did this in a mountainous area because it's not farmland. And so now they have a massive erosion problem. They chop down a bunch of trees. Okay, that doesn't sound like a good idea to me, since trees produce oxygen, convert carbon dioxide to oxygen, and basically created a erosion problem.
Yeah, I could tell 100 stories like that. I'll mention one, and that is, Australia has had really bad fires, which of course were blamed on
Well, I didn't talk
climate
about that
change.
much.
But a study was done, and it was shown that it was government actions
Right.
that caused these fires. One of the things they did was they killed all of these animals that eat vegetation, large animals that eat vegetation, including hundreds of thousands of donkeys that had been imported and were one of the great drivers of Australia's growth economically. They killed them all, and that left all of this brush to grow and grow and grow, and it was the feeder to these great fires. So,
well, that's an issue here in the United States, which is, apparently there has been in recent years. If you look at Tony Heller has a chart that shows the wildfires in the United States, and they've been slightly increasing in recent years. And a lot of people say that's due to bad forest management, as you
Yeah.
refer to. Okay.
I noticed in one of Harry's websites that he recommended, during the 30s, when it was so bad all over the world, it was so hot. A lot
Yeah,
of
the
tankers-
1930s in the Dust Bowl.
Yeah.
yes,
This
yeah,
country, but it was in other countries too. In Europe, they started up some old religions that had died out, where they would dance around in circles and so on, doing all various things. And I think that that this is what is happening on a more sophisticated level in this country now. The people like Al Gore are the new shamans.
Yeah.
And the people that all the people they could scare into working with him are the new I don't know what you'd call them, the new dancers around in circles in the old rites. It's actually when you come right down to it, it's a cult situation.
yes, yeah,
The high priests are raking in the money like you wouldn't believe, and they're scaring everyone. And then if they pass $500 billion worth of climate change legislation, then they let up the scare tactics a little bit until it's time to appropriate again. So it looks as if things are improving, and there's not so much to be scary about when actually the whole thing was a propaganda blitz.
yeah. In the 30s, you not only had the droughts equivalent to what we have now, but the Arctic melting was equivalent to what we have now.
Yeah, it looks like a lot, my thesis is, and I believe this, like Tony Heller is saying this, and other people who are critics are saying this, that these climate changes are cyclical, and basically to claim that something that's part of the climate and has been part of the climate or weather patterns for a long period of time, and claim that that's changing and point to that as a cause is not really correct. So, apparently we don't know as much as we thought we did, or they claim they did. But I think this exercise is revealing more about what our climate is. And maybe from that point of view, it's useful. We know more about the Arctic ice melting and growing, that's cyclical. And you can see that in the historical record. And he has newspaper articles that talk about this. So, we learn more about what the climate actually is.
It's certainly all very interesting, but one can speculate why this has had a grasp so much on the populace generally. And you don't get people saying, oh, look, maybe it's been exaggerated or something. No, they say, no, it's actually worse than that, and it's a catastrophe. And you know, as Denny said, and I think was mentioned earlier, it's maybe a continuation to a certain extent of people's wish to be frightened. You know, in the old days, the world is going to end because you haven't done this, and the gods are going to destroy it, and that's the end. This is a replacement. It's a secular replacement for this catastrophe that the world is getting bad about. People want to be frightened. They're not questioning it at all. They're not questioning politicians. I don't even think it's as simple as people saying, "Oh, we'll get rid of fossil fuels and we'll introduce this big conspiracy." You know, when we start talking about special relativity or something like that, the ordinary man in the street says, "Oh, that's beyond me. That's complicated. I couldn't understand that. So I just accept what the experts tell me." Now, in this case, one can look at these graphs, and actually they're not very difficult to understand. I mean, the ordinary educated person could maybe have a look at them, but they're not willing to. They say, "Oh yes, it's even worse." And you hear this thing daily. "Oh, we've just discovered that it's even worse. The new research has been done in this university, and they found it's actually worse than we thought." You never hear, "Oh, maybe we exaggerated a bit. It's actually not quite as bad."
Well, it's also that the media, this is one of the messages of mainstream media. And I just looked at Facebook has now gotten, I think it's called Climate Science Center, where it listed all of the claims that Harry had listed, and is a tremendous propaganda machine. Virtually everything on that website has been proven false, if you care to look. It's a climate propaganda center. One other thing that occurred to me was we were talking about CO2 during the so-called global warming period. CO2 had indeed increased in density in the atmosphere, admittedly behind the so-called warming, but that there was a paper called The Greening of the Planet, which showed that this increase in CO2 was tremendously beneficial to to vegetation. And the problem of blaming it all on CO2 is that then you don't get after the real problems that humanity is creating, like cutting down the Amazon forest, which obviously will have bad negative effects. But anyway.
Okay. Is everybody, I think we're going to get cut off here pretty soon. And we go to the third segment. I guess we're going to talk, we could talk a little bit, and I want to talk about this a little bit. I think Dennis has more to say.
Yeah.
About the historical changes going back millions of years and what's causing that. Okay, we talked about that. We'll talk about that a little bit in the third segment.
The idea is that how could the sun's radiation drives the weather, and if you don't know anything, if you're missing half the solar radiation because it's not believed to exist, maybe longitudinal radiation, then it's clear that you're not going to make too much progress in figuring out how the sun drives the Earth's weather when you're missing a whole, maybe half of the photons or rays that come from the sun that are not transverse radiation, but longitudinal.
Like I mentioned the younger dryas thing earlier. And I hadn't really thought about this a whole lot, but the issue kind of is, how is the climate, how is this global temperature, if they're actually measuring it correctly, how is it changing so drastically? I mean, it's drastic changes that have occurred in the past. What's causing that? Why is that happening? And I guess my feeling is it must have something to do with the sun.
Yes, and it's radiation.
Correct. Now, we know that solar, the assumption is that the sun is unchanging in its output, but we know stars aren't constant. Okay, lots and lots of stars vary. There's variable stars. We know a lot about this. And so the assumption that the sun is not changing in its output would strike me.
Yeah,
Okay, so my point is the constancy of the solar irradiance is an hypothesis.
There seems that there should be some correlation, but it's quite pronounced that all the research institutes from NASA down have major articles saying, no, it's not sunspots. We've done this. It's not sunspots at all. That is incorrect. They
Huh.
are contradicting that.
well, they are willing to admit that low sunspot activity is correlated with low temperatures, but that other converse they refuse to accept.
Yeah, we talked to, I showed you the chart, and there's people who, have theories on this, and but it's just not flying with the establishment, and it seems like they're locked. I guess, it's when you have a satellite and you're measuring the solar output, and let me find the chart. Let me see if I can find the chart, and you guys can carry on a little bit.
Well, they don't understand solar radiation in general. So in particular, they don't understand solar radiation. They think that it's all transverse wave when evidence is a lot of it's longitudinal wave. And they have different properties. And the properties of longitudinal radiation can't be studied because anyone who mentions that is declared to be an enemy of the science. And then if that weren't enough of a problem, they don't know whether it's true anymore that hydrogen is being burned into helium in the solar interior because they say that the neutrons being produced aren't in the right numbers, or not neutrons, neutrinos. Excuse me, I got hay fever. So they aren't even sure what's going on in the sun as far as powering it. And then when there is radiation, they don't know half of the radiation that occurs. And also, they don't seem to take into account radiation outside the visible spectrum as much as they do inside. But how do they know that's a good idea?
Okay, the red line is what they claim to be the temperature, the global temperature, and the yellow line is what they claim to be the solar irradiance. And gosh, look, there's a big divergence there. That's their official position.
Wow.
Well, how do they measure that radiation though when they don't know half of the radiation even exists?
Yeah, so essentially one of the things to note here is that this solar irradiance scale is, there's like 1 inch between a change in the units. So they've exaggerated the irradiance scale so that any small variations get exaggerated. And the temperature scale is also kind of exaggerated. It's like in tenths of degrees C, type thing. So, that's kind of exaggerated too.
And the data is suspect as well.
Well, yeah.
On temperature.
Yeah, they're showing global warming in the red line, yes.
Yeah.
And what, and I don't know here, temperature. Okay, what's the, what's that? Some kind of a big average, or they kind of show these little variations. There's a red line that shows a little wobbling around. I don't know what that is. Is that a smooth line?
It says as up above 11-year average, so it's a solar cycle average.
Well, yeah.
I'd
right.
certainly say that the solar irradiance is constant over that period from 1880 to 2020. They're talking about a fraction of a watt per square meter difference.
Yeah.
Right.
Very small.
It's, yeah, you've got you know, the real question you have here is, okay, now you've said that the sun isn't a factor. All right, now that leaves a lot of other things to talk about and discuss. Okay, but if we go back to this chart here, where we have the younger Dryas, you know, this big change here. Okay, what caused that? Here's another chart for the younger Dryas. That's is that better?
Yeah.
Wow. Yeah, it's dramatic. Mm.
Big drop, you know, where the red arrow is. Okay, so that's a big change. I mean, this is, you know, you got like and then a big increase, air temperature in Greenland. And apparently they're measuring pollen seeds. There's this plant called the Dryas something or other. And I guess they look for the seeds of this plant and they can identify the seeds. And so that's apparently a proxy for the temperature. And I guess you could argue whether that's correct or not. But this is the data they come up with, and you know, it's a big change over, you know, and this is age in kilo years. So this is not, you know, millions of years ago. This is like 10,000 to 15,000 years ago.
Yeah. And that was the ice age, the last ice age.
Right, right. And that's a big temperature change. What's that about?
So I have a question for Dennis.
Alan, how would these longitudinal waves be measured or received? What kind of antenna?
Well, they used Wesley used a spherical aluminum antenna of diameter 3 centimeters, radius 3 centimeters, and then with a little handle on it, he drilled into it and then ran a coaxial cable almost all the way to the center. And then the inside of the coaxial cable has got an outside cylinder conductor and an inside wire conductor. They extended the inside wire by a brass rod to the edge of the sphere, the aluminum sphere. And then it's like a whip antenna. Are you familiar with whip antennas of radio amateur?
No.
Well, it's an antenna that's a rod or a wire, usually a rod. It has a connection at one end, but no connection at the other end. It's not a dipole antenna, which has connections in the middle. So it's sort of an open circuit antenna. You'd say, wait a minute, no open circuits, no current in open circuits. But the whip antennas, if you look them up on the web, they've been selling them for years, decades. And so you have electrons shooting out into the antenna and then shooting back into the antenna, where the electron flow is in the opposite direction of current, unfortunately. And so at, you know, say 2 meters or something like that, you can talk, if you have like a sort of like a like a phone in your car, you can, you have call letters and everything. The FCC licenses you and so on. And this is, but they stopped making whip antennas pretty much because people would start breaking them off as a prank. You can just break them right off. So they don't use them as much as they used to. And anyway, so the brass rod serves as a sort of a whip antenna, which would be a transverse wave antenna, not a longitudinal. But since the aluminum has a less resistivity, about 2.65 times 10 to the minus 8, compared to the brass resistivity, which is 3.5 about times 10 to the minus 8, the current tends to exit the brass rod and go into the aluminum. And so you get a merging of two effects. The brass rod is a longitudinal transverse wave antenna. It's hooked into the coaxial cable, which is inside the sphere. And the longitudinal radiation comes from a center-fed sphere. And so it has to be spherically symmetric, which means that there's no magnetic field, no B field, but there is a magnetic A field where curl A equals B, which in this case is 0. And so you have your two types of antennas, and you sort of have a continuous spectrum between the two types of radiation. And so let me show you here if I can do this. I don't know how to bring my picture back to the center of the screen. Well, anyway, I'll hold it up. Maybe you see that little plot there. That's plotting a frequency versus the stray factor, S11, which is measured by a vector network analyzer. And it measures the valleys, the notches, as they call them, are measured, the notches are where the more radiation is going out of the antenna. And the higher the graph, the less radiation is being radiated, and more is being kicked back into the system. So there's two notches in that graph. One of them corresponds to the brass rod, which is the longitudinal radiation, which is ordinary transverse radiation. And the part that goes out into the aluminum ball tends to be longitudinal radiation, because since it's spherically symmetric, there can't be any magnetic field, only a field, a magnetic vector potential field. So they're definitely different. And Wesley, in this paper, which I sent everyone a copy of earlier today, maybe you didn't notice that, by Wesley and a colleague, Monstein, they measured all these various things and wrote a paper on it, which was attacked immediately because that would mean they'd have to give up Maxwell theory. They haven't even gotten to the point of giving up Maxwell theory for Hertz theory yet. So how are they going to give it up for this? But then someone redid all the experiments. A guy by the name of, well, there was 4 guys, but Butterworth was E.J. Butterworth. It's called Longitudinal Electromagnetic Waves, the Monstein-Wesley experiment reconstructed. And here's what they say. Therefore, we constructed a duplicate of MW's apparatus and ran their experiments along with some additional ones. We intended both to test the MW's results, whether they could be duplicated, and distinguish between their theoretical model and that of a critical article published by some other guy proposing so on. We determined that the field pattern of the ball antenna, we also determined the field pattern of the ball antenna experimentally. Our experimental results actually resemble MW's, that's Monstein-Wesley, theoretical patterns more closely than their own experiment. An interesting result, considering that MW's theory is almost universally considered to be incorrect. But then they say that one of the experiments they ran didn't pan out for Wesley's theory, so they ruled out, at the end of the paper, they ruled out the possibility of longitudinal radiation. But I think what's going on here is that if they were to admit that all of Wesley's experiments were correct, or even more, their correct version even more correct than Wesley's and Monstein's, then what they'd have to do is admit that longitudinal radiation exists. And I don't know if you ever worked at a university. I taught at Michigan Tech for 3 years in the late 60s and early 70s. And the next thing would happen if you published or even started talking about something like that would be the chairman of the department would call you in and ask, well, are you trying to sink our ship? You know, but this is Professor Emeritus James Walter, who has a laboratory, and we're slowly working towards designing and doing an experiment which will show that this one, hopefully will show, we're not predict, that it will, but hopefully it'll show that the one experiment that Butterworth and all couldn't agree with Wesley's was because they were obfuscating. They didn't want to be in a position where they had to say everything Wesley and Einstein did was basically correct. I mean, that would that'd be about the same level as saying SRT is wrong in a paper. Bill Lucas tried that and they fired him in 48 hours.
Yeah, I know that Bill Lucas is an advocate of the longitudinal thesis. And my question would be, I'm thinking how these measurements would have been made. And since we pointed out that they go back to 1880, they would have used a different measurement technique probably than what they're using now.
Yeah.
And so I guess basically that'd be something worth looking into. What are they using as a measurement device? Now, I think I mentioned the bolometer, and I can't remember exactly what a bolometer is, but I believe it's a device that detects temperature change as a result of the sun. So in some way or shape or form, it measures the amount of energy that's being intercepted by the measuring device and converts that into some, usually in a modern system, I would assume that's a electrical measurement, but maybe in the 1880 or whatever, they had a thermometer that would measure it.
Yeah.
But I have to admit, I don't know how it's being measured.
Yeah, they might not want to have too much specific information out on that nowadays.
Well, it's not an easy issue because the spectrum of the sun is pretty wide band. So you would have to have a device that would measure from the infrared, I'm assuming. Now, this is okay. So this gets you into the weeds. What are they measuring? Are they measuring the whole spectrum? Or are they measuring just the visible spectrum? Are they measuring ultraviolet? Is that being measured? And then that leads you to the question of, we know that the sun, it has different wavelengths of radiation, and ultraviolet radiation.
Radiation. They do the best they can, but they've taken the position that everything is longitudinal or transverse radiation, not longitudinal. Now, if that's not true, and some there are people who think that it isn't true, then how are their conclusions going to be right when their premises are all wrong?
So you're saying we have two premises that might be incorrect: the constancy premise that the sun doesn't change in its output of any significance, and the premise that the measurement that the radiation is transverse radiation, and we might not be measuring all of the energy correctly.
Yeah,
that's what you're saying. I think the sunspot theory has something to do with that they're saying that the increase in solar activity, which is correlated with sunspots. So you have we radio amateurs know that when the sunspots are high, there's a lot of sunspots, you get more, better propagation.
If it goes off the ionosphere better.
Right. Well, you get a lot of ultraviolet radiation, which excites the ionization layers in the ionosphere. So when the sunspots go up, the ionization of the ionosphere is increased on these higher frequency bands. So you get the radio waves are refracted better at higher frequencies. So there's more high frequency radiation from the sun during these periods of solar activity. Plus you got all the solar storms, and guess what? You've got solar flares, which generate a tremendous amount of energy, and they're highly correlated with sunspots. So, you know, solar flares occur in sunspots. And when the solar flare goes off, it releases all these particles. You get coronal mass ejections and all kinds of, you know, I'm not an expert on this stuff. So that's, you know, lots of other things are happening on the sun during periods of increased solar activity, which are indicated by sunspots. Now, if sunspots are low, that indicates low solar activity, which would tend to say, oh, that's not making the Earth hotter. So that, yeah, that's when it's colder. Reduced sunspots, the Earth is colder, right? So less solar activity, less high energy events, less solar flares. David, did that answer your question?
Well, there's a big controversy about the existence of longitudinal electromagnetic radiation, extreme controversy in the physics literature. However, in quantum field theory, they talk about longitudinally polarized photons all the time. There's two types of transverse polarized photons, a temporally polarized photon and a longitudinally polarized photon. So it's crazy.
Yeah, well, this, I don't know enough about it to comment.
But you've possibly seen some correlations that have been made, you know, by the classical economists like Say and so on, between the sunspot cycle and all the vicissitudes of our civilization here on Earth. So in other words, the harvest, the frugality of the harvests and the quality of the harvest is correlated with the sunspot cycle, and therefore the sort of periods of plenty and of recession correlated as well, and the periods of peace and war on Earth. You know, so sine waves going back with very good correlations.
Right. I did want to point out that, as I recall, Tony Heller mentions in one of his videos that in the 1920s, I believe it is, that they believe there was a scientific, a lot of people who published that the sunspots did cause climatic, you know, all these severe storms and distress that you referred to, Ian. You know, that this was caused by the sun, you know, droughts.
The magnetic storms they talked about.
Right. Right. And this was talked about in the early part of the 19th century. So, I mean, 20th century. So it's not a new thing. It's not a new concept. It's been around for a while. It's just not really nailed down enough so that at the present time, it looks to me like, you know, they want to really ride the carbon dioxide thesis for what's causing it.
Yeah.
And my guess is after the, you know, I see this coming, after they, you know, get all the money to do their green energy transition, that's what we call it here in the US, that the next thing is going to be forcing farmers to stop using fertilizer because that causes nitrous oxide, which is 300 times more potent than carbon dioxide.
Well, yeah, I'm sure they will. You know, they don't care if people don't have enough to eat as long as they have enough to eat. No, they don't.
Well, yeah, that boggles my mind when I read that. I mean, I hadn't really been paying attention. I couldn't understand the Dutch were protesting about, you know, all these things that they were doing. I couldn't really quite understand. It wasn't really explained very clearly until I went online and looked at this, and they were saying, well, you know, these ammonia-based fertilizers they put down, the nitrous oxide is apparently released as a result of reactions that occur when it's been in the ground. And I don't know about the chemistry of it, but yeah, 300 times more potent than carbon dioxide as far as a greenhouse gas. That sounds pretty bad, really. If you read, you know, I mean, that's like, wow, 300 times worse than carbon dioxide.
You may have read, I don't know about what's been happening here in Ireland, because as you know, perhaps in common with countries like Scotland and Finland, we have an amount of peat in the Midlands, which has been put down from the decay of hundreds of years of maybe longer of vegetation and so on. Well, anyway, the European Union has wanted to ban the use of this completely, ostensibly because of its carbon dioxide content when burnt. And yet during the sort of energy crises in the 70s, because I was working in the area, we were all lauding the qualities of peat because it was a smokeless fuel in comparison with coal. But anyway, now it's the devil incarnate. So we've closed down admittedly pretty small peat generating stations in the Midlands. But anyway, the controversy arose in June when you've had farmers all over the country who've been taking in some of the sods of peat and putting it in their fireplace and burning it, and maybe giving it to neighbors who needed something. And they were going to say, well, that's illegal. You'll have to go to jail now, and so on. And there was an upcry here. So what the government have done is they've got a derogation until September. Well, it'll have to be reviewed very shortly. So it's not allowed to use peat for commercial purposes. But you're not a criminal if you take in a little peat from your own field, if you're in the Midlands in Ireland, and burn it in your own fireplace, or give it maybe to a neighbor who needs it. So that's been a stay of execution has been given on that. For
my understanding is that peat is a traditional fuel in Ireland.
Was Harry, for hundreds of years, but the EU have basically brought in a law at the beginning of the summer, which basically said, no, you must stop burning it completely now. So the peat board, which has been developing all these fields, has now been diversifying. So they're doing things like they're not harvesting the peat, they're not digging the peat up anymore. They're not transporting the peat. They're using the products for, say, filtration purposes. That's one thing that they've been doing with some success. Another is they're growing short rotation forestry on the cutaway bogs, and then they're cutting down the trees maybe after a few years and using them for biomass. So it stopped now. No commercial development of peat, and the controversy is private use of it.
The whole thing is crazy. It's crazy from top to bottom, end to end.
Well, things have just changed like that very quickly. And the other thing, relative to what we were talking about earlier, is I put this business about the ozone layer to some person who had worked in the public service. He had a significant job in the energy authority. And I said, look, years ago, they were all talking about the world is going to end because we're getting ultraviolet radiation in over the South Pole because of the ozone layer and so on. And, we changed all these propellants and all that. But you don't hear about it now. I said, it's all climate change. So his answer was, oh, yes, that proves it was successful. The methods we used.
Yeah.
But that's opposite to what you said, because I thought you said earlier, Harry, that they were saying that it appears that they haven't solved the problem. He said, yes, it's patched up now. There's no hole in the ozone layer anymore.
Yeah, I tried to look into this, and what I read was vague. And, I didn't really get an answer that the hole was gone or it wasn't gone. It was more like, oh, yeah, it's fixed now, but the hole hasn't been completely eliminated, that sort of thing. And this is the other issue I want to point to, is apparently the people in Australia are resisting the notion that climate change isn't causing the reef destruction. And they're apparently trying to say, oh, but the coral that's growing back isn't good coral. And so, this is the sort of thing. And then there's the other thing they could say is, if the hurricanes don't increase, and all these bad things don't continue to happen, they'll say, see, it worked. What we did worked. Right.
Yeah,
so they've got this tails we win, heads we win type of, it goes heads I win, tails you lose, approach to the issue, so that they come out ahead no matter what happens. So if it turns out if we spend billions and billions of dollars and nothing and everything is fine because there never was any real climate change to begin with to fix. They'll claim victory anyway.
Harry, did
You
you,
realize that the 1995 Nobel Prize in, I believe, chemistry was given for this whole ozone depletion theory?
Yeah, I think I read about that. I don't really mind them doing that so much. I mean, the halon thing really ticks me off because, I mean, I think halon was one of the greatest chemical inventions in the history of mankind. I mean, there's a lot of them there, but I think that was one of the greatest. I mean, it's amazing fire suppressant. It doesn't harm humans. And if a fire starts, you just turn on the halon device. We had these devices when I worked in the earth station business. I mean, you know, and it detects the fire and it turns on the halon and the fire goes away.
But I've also understood that a number of these things which have become accepted science haven't originated among maybe the plutocrats who had interest in doing that or something. They've actually originated with like hippies, with, you know, with out groups. So, for example, even with this whole global warming business, it's understood that you had hippies in Germany, maybe in the 60s or 70s, who were measuring the height of the rivers, the inland rivers, and they found maybe they'd increased some years. So they put out a big scare that the water levels are rising and they're going to inundate the land within 30 years. And, you know, they were considered as nuts. But then within 30 years, you get all the interest of politicians and you get the big industrialists and the media people, and they just get into this, and it becomes part of accepted science.
Yeah, accepted science reminds me of the claim settled science, which has to be an inherently anti-science, because all that says is if you disagree with me, you're arguing against settled science. So we dismiss all data or all logical arguments against what I currently believe, or even maybe I'm just peddling something that I don't even believe myself. But
yeah, well, all these things should, of course, be subject to discussion and conversation.
Especially something like global warming and climate change, which has got to be so complex and so multifaceted. You need to have open discussions on it.
Well, they passed that bill in the dead of night. There's no way the Democrat Party was going to discuss their big spending pork barrel bill. They just basically said, oh, we have an agreement. This is what the bill is. And they rammed that thing through. They didn't tell people in the public. There was very little public discussion. And the thing was just rammed through. And the one Saturday night, next thing you know, you wake up the next morning and they passed this bill, $700 billion bill for climate change and a bunch of other stuff. But I don't think they want public discussion. I don't think they want.
No.
And in defense, it's much easier to engage in name calling. So you say, well, you're a denier,
exactly,
or you're anti-science, or you're this, that, the other. That's the easiest way out.
Well, the other, I don't know. To me, this is kind of, the whole thing was kind of, well, of course, it's politics, but you know, in Germany, they apparently are very dissatisfied with the windmills, and I guess they're using this business with Russia to sort of bring back the nuclear power back, and they're doing it in a way that makes. But you know, the windmills, apparently, the price of energy apparently skyrocketed in Germany, and they apparently have gone further than any other country as far as the implementation of these policies. And my understanding is that the price of electricity was just really, really, really steep in Germany. And then the Germans apparently didn't like the fact that all these windmills were everywhere. They ruined the farmers' fields, they claimed. And of course, then they found out that it killed these the birds and the bats, I think it was. And so that kind of didn't really work out. So there's really not a lot of thought put into, you know, is this really a good thing to do? That really isn't part of the discussion. So let's assume that, carbon dioxide emissions is a bad thing, which we don't know. So yeah, okay, green energy is renewable energy is the solution. Well, I don't think they've worked out all the problems that's going to create.
Exactly.
So it's just jumping from one. I think I mentioned one of the problems, which is, they knocked. Here, we had a big controversy. The local power company wanted to put a solar array in North Carolina, and where the farmers in the farming area, okay, you go south of here, you go down and cross it into the border in North Carolina, and it's farming area. And the people in North Carolina, they did not want windmills and they did not want solar farms. They really opposed it, and I don't think they were very successful. So that's another issue. And apparently in California, they have a problem where people are really upset about all the solar farms that they put in the desert. Oh, we could put them in the desert. People won't mind. Now the people don't like that either.
If you talk about unintended consequences, they can't deny that. But what they say, this is so important that it doesn't matter. We have to
it doesn't matter.
not consider those, because the world is going to end in 5 years' time.
Yeah,
Right.
Come hell or high water, we've got to go, and we got to go now.
Yeah.
Well, here in the United States, they got their $700 billion so they can prevent cow flatulence.
Yeah.